previously we looked at experiments that were one characteristic or maybe two characteristics of a single event. Those were what would be considered one-stage experiments. We were just doing things one time. Now we're going to look at two-stage experiments or multi-stage experiments in which things happen multiple times, such as rolling two die or selecting two cards, things of this nature. And so if you think about a student that rolls two dice, we can construct the sample space in multiple ways. So let's say that we roll a red die, and then we also roll a blue die. Okay? And so on the blue die, we have the options of getting a 1, 2, 3, 4, 5, or 6. And on the red die, we also have getting a 1, 2, 3, 4, 5, or 6. And so if you think about the sample space, you have to think about on each of these 1 through 6, I can actually get each of these values. So if I think about a tree diagram, I'm going to spread these out a little bit. And so for each of these 1, 2, 3, 4, 5, 6, I could actually get a 1, a 2, 3, 4, 5, and 6. Okay? I could get a 1, 2, 3, 4, 5, or 6. So I would actually have 6 branches coming off of each of these values. I'm going to come down here so I have a little bit more space. And the reason why I chose two different colors was so that I would notice that each die, just because I get a 1, 2, doesn't mean that it's the same 1, 2. It could be a 1 on the red die and a 2 on the blue die, or a 1 on the blue die and a 2 on the red die. So those would actually be two different items on my sample space. And so this is one representation of getting our sample space, is we can do tree diagrams. And so if I were to list this out, I would get a 1 for each of the 1, 2, 3, 4, 5, and 6. Okay, and I do the exact same thing with the 2, the 3, the 4, okay? Another way to look at this is we can do like a table. And if we think about our red die, we have the numbers 1, 2, 3, 4, 5, and 6. And then we think about the blue die. And we can get 1, 2, 3, 4, 5, and 6. And we can kind of do like the cross and everything with those. And what I'll do is I'll just come down through here with each of my columns and go ahead and put in all of my red options. And then I will come back in and enter all of my rows with my blue options. And this will give me my sample space. Now, trying to figure out how many total values are in my sample space is another issue that we sometimes have. And so we need to look at how many options there are for each value. I'm going to come across with all my 1s for my blue, and then all my 2s, and so forth. And these should be all 3s. And you'll keep filling in the table. You'll notice I went ahead and filled in the table. And so if you'll notice right here, I have 6 options for the red, and I have 6 options for the blue. And so I can do 6 times 6, which is 36 possible total options. So that is my total number of items in my sample space. This is like our fundamental counting rule. You kind of look at how many total options you have, and that will give you your total value. Now, when we determine the probability of the sum of 9, what I'm going to do is come down here, and I'm going to look at, I want the sum of 9. So numbers that add up to 9, well, this adds up to 7, 8, 9. So this adds up to 9. This only adds up to 8. And you will notice on the diagonals here, those add up to the exact same values. So if you notice, like through here, this long diagonal here will add up to 7. This diagonal will add up to 6. 5, 4, 3, and 2. Here we have 8, 9, 10, 11, and 12. So we have 1, 2, 3, 4 pair that will add up to 9. So that is 4 out of 36. So that's the probability of sum of 9. And that can be simplified into 1/9. Now, if I look for the sum of 2 or 11, this is our only option for sum of 2. And then sum of 11, I have 5, 6, or I have 6, 5. So when we're looking for ORs, I have the probability sum of 2 plus the probability sum of 11. And since there's not any that are the sum of 11 and 2, I don't have to subtract anything out. So I have 1 out of 36 plus 2 out of 36, or 3 total out of 36, which is 1 out of 12.